In this lesson, we will deal with the question of why machine learning. And as you will see, machine learning is quite different from programming, but what can be achieved with it often overlaps with what you can do with programming. And this brings us to the objective of this course. Imagine we are in the car insurance business and want a system that predicts the risk of accidents for prospective customers. And in the end, we want a system that looks like this. We want a fully functional application. This is our running risk prediction calculator now, and it's actually working, so it's not a dummy. What you can do is you enter some data for a prospective customer, like the top speed of the car of the customer, the age of the customer, and the miles per year that the customer drives. And then you calculate what's the risk of having an accident. This customer data results in the low risk. But if I fiddle a little bit with the age here, a young driver, that's a medium risk, it's a little bit higher. And then if you're pretty old, then probably the risk also goes up. So as you can see, for this course, this means we also need to go into production. So suppose that for our example, we already have some data. And this is the data of the existing customers. Each point that you see is a sample from our customer database. And we've restricted ourselves to 2 dimensions here, even though we would have many more. This data is not real data. It has been generated by me, but it has been generated based on assumptions of actual driver risks. In these samples, you have these 2 dimensions, as I mentioned, the age on this axis and the top speed. But you also have a 3rd dimension, and this 3rd dimension is the risk group, and it is encoded in the color of the samples that you see here. So the yellow color means it's a medium risk. The red color means this is high risk. And the green color means low risk of accidents. Let's consider me as an example. I'm 47 right now. I'm drawing the 47 down here. And the top speed of my car is 100. It's not a very fast car, to be honest. So around here. So this would mean if I go down here and here, I would be around here. So what would you think? What would be my risk assessment? You probably would say it's green. But how do we encode this into an automated system? And the programmer's approach would be to code some rules by hand. And the rules would probably come from some experts, and they might look like this. So this is our first rule. This rule is in Python, but it could be any programming language. And it shouldn't be too hard to understand. So in line 1, we are checking the age of the driver. If the driver is younger than 25, then we have additional checks. If the car is really fast, more than 140, that would bring the customer in the group of young drivers having fast cars, and this is high risk. And if the driver is just young, but the car is not so fast, that's probably a medium risk. Now, the next rule, if the driver's pretty old, I mean, 75 is not that old, but, well, that's just our rule, then we just say that's probably a high-risk customer. And then we can also take into account the miles driven per year. And if the driver drives a lot, then high risk. If the driver drives in the medium range, then medium risk. And then eventually, if the driver does not fall in one of these groups, it's probably a low-risk customer. What we can do now is we can plot the predictions that will come out of these rules as a background to our samples. And as you can see, these are exactly the same samples as before, same dimensions, age, max speed, but this time the background would also encode the prediction for each of these data points. That means if I look up here, then the prediction would be green. So even for unknown data, prediction would be green. Now let's double check with me as a customer, and I was at around 47 down here. 100, that would bring me up here, I guess. and the prediction would be green, and that is quite correct. But you also see in this plot that it's not really sophisticated. I mean, it's also questionable, are old drivers bad drivers? I mean, that's encoded in our rules. Is that even correct? And then also, is all this big area, is it like this one here? Is it all green? Is that even possible? Even if you look at the data points that we know, there are so many errors in here, like this one here. Not correct. And also, I mean, what is with this part here? And then there's also some yellow stuff down here. And then also, what is this area here? So our rules might not be the best you can get. And as it turns out, even on the data that we know, it only predicts 43% of the samples correctly. Now, how good is this? Is it better than guessing? And then, are all the rules correct? We even questioned already the rule for the older people. Is that correct? Aren't there some older people who are great drivers? And now, also some rules missing. You saw that the groups we could separate with our rules probably were too coarse. And then, maybe most importantly, how would we even know if these rules are good? How would we measure that? And this brings us to the approach of this course, and we are using deep supervised machine learning. And machine learning is a little bit more like lab work. That's why I'm wearing my white lab coat every time I do machine learning. It's a little bit dorky, to be honest, but it does its job. So people see I'm doing something different than coding now. And the model we will create in this course, the machine learning model that does the prediction, as a replacement for the rules that we had before, it will have predictions like this. And as it turns out, it can predict correctly up to 80% of previously unknown data. So for prospective customers that apply for an insurance, it can predict with 80% accuracy if this customer is going to be a good customer, a bad customer, or a medium customer. Look at the groups that are separated using our machine learning model. All the criticism that I had, like this group down here, and then what about our old drivers, and then how this is separated. These groups are separated from each other really smoothly. And as someone who has some experience with machine learning, just by looking at these boundaries between the groups, you would see that this is a pretty good result. We will use neural networks to do this classification. And to get started easily, we will use the so-called TensorFlow playground that helps us to understand some of the basic concepts. There's a lot of material out there that teaches how to tell cat images from dog images, or how to train a recurrent neural network to create new names for Norwegian heavy metal bands. This is all nice and fun, but practical examples typically look very different. So we have chosen such a practical example that might be a bit less exciting, but can be adapted easily to challenges you might face in your daily work.